All right, so I'll run through this pretty quickly. So completely factor this expression right here. So I sent you just a sheet just a few minutes ago. And like the first step for factoring every time is always check for a greatest common factor. So in this case, we're dealing with a 48 and we're dealing with a -3. And so you just want the biggest number that divides into them both. And so 3 goes into 3, and that's the only number 3 is divisible by. So you're hoping 3 goes into 48, and it does. Um, so like we could take out a 3 now from this. Let me grab my pointer. You could take a 3. There we go. You could take a 3 out of both of these terms, or you could take a -3 out of both of these terms, right? A negative sign would just flip the signs on each term. But if you look at their multiple choice answers here, they've just taken a 3 out. So we're just going to pull a 3 out of both of those. And when you do that, what you end up with, there we go. I take that 3 out, and so you divide this 48 by 3, and that's what goes inside your parentheses, because now 3 times 16 is that 48. And you do the same thing. You divide -3x squared by 3, and the 3 over 3 just cancels, so you get a negative x squared like that. So that's always our step 1, and that's at the very top of the sheet that I sent you. Then you move on to step 2, and step 2 in factoring is look at what's left over and count the number of terms it has. It either has 2 terms or it'll have 3 terms. I don't have anything with 3 terms on the screen right now. Or it could have 4 terms. This is just a 2-term one. And once you know it's 2 terms, you can see on that sheet I sent, there's only 3 possibilities. It's either like 2 things squared with a minus sign, or it's 2 things cubed with a minus sign, or it's 2 things cubed with a plus sign. Well, this one is obviously a minus sign problem, so it's one of these two, and it's certainly number 1 here because of this x squared. Okay? And there's just a rule for how this factors. And that rule's on the sheet, but I'll write it down right here. This is called the difference of squares, but it always factors as a minus b times a plus b. And so the real problem is when you have a difference of squares is you got to figure out what the a is, you got to figure out what the b is. But it turns out to be pretty easy because this number right here, you just need to square root it. Square root of 16 is 4. And so that's what a would be in this case. A is a 4 because that's what's been squared to give you 16. And when you square root the x squared, that's just an x. And so that's your b. And so this factors as 3. And then it's a minus b, so it's 4 minus x. And then the formula is a plus b, so that would be a 4 and an x, so that's 4 plus x. And that's how it factors. Okay, so if I remultiply all this together, I'd get right back to this. But factoring is unmultiplying and showing how it would be written out as a multiplication problem. So now we just got to pick it out of the lineup, and it looks like it's this guy right here. Okay, so those are the steps. These two you probably haven't done yet in class. You don't even have to worry about those two right now. It's probably these difference of squares and then trinomials that you've been working with, or you will work with. So number 7 here, let's see, which represents the greatest common factor of the terms. So let's talk about GCFs for just a little bit. So you do your numbers separate from your variables. A lot of students think GCF just means look at the coefficients. No, you also have to check variables that are common. And the first thing you want to remember, I guess I'll step back just one step, is that this really means 4 times x squared times y to the 6. And this, 18, is really 18 times x times y to the 5th. And so by definition, since this is all multiplied together, each one of these is a factor. So 4 is a factor of this term, x squared is a factor of this term, and y to the 6 is a factor of that term. Okay, so those are all the factors, these are all the factors, and we're trying to figure out which ones they have in common, and actually the greatest ones they have in common. So if you're good with your numbers, all you do is figure out what's the biggest number 4 divides by and see if it goes into 18. Well, 4 can be divided by 4, but 18 can't. So that's not the biggest divisor then. Then you go to your small number and just figure out what's the next biggest thing it divides by, and that would be a 2. And 18 is divisible by 2, so 2 is the greatest divisor or the greatest common factor that they have. And you could actually see it. Like if I started to break down the factors of 4, it's 2 times 2. 18 is a 2 times 9. So what factor do they have in common? That's the 2 that they both have in them. 4 has another 2, and 9 has a couple of 3s. That's what 9 is, 3 times 3. But the common factor they have is that 2. And so that's the number we're taking out. So we'd say, hey, the numbers have a GCF of 2. But then you got to do the variables. And the variables are actually the easy one because they tell you how many x's you have multiplied together. So this one has a pair of x's that are multiplied together, but the other one only has a single x. So how many x's do they have in common? And they only have one x in common. So that's their greatest common factor. And the truth is, when you look at them and they go, oh, they both have x's, just grab the one with the lower exponent. That's what they have in common. They don't both have 2 of them. They always have the lower. Same thing with y's here. They both have y's. Well, how many in common? It's the lower number because they both have at least 5 in them. This one, the second term, only has 5, so that's the most you could take out. And that's it. Okay, so we're looking for a 2xy to the 5th. There we go. All right, moving on. Which of the following is not a factor? All right, well, there's a couple of ways you could do this. First thing is, we'll just check like numbers. So like 6 and 18, start with the small one. 6 is divisible by 6. Is 18? Yeah, 18 is divisible by 6 3 times. So they both have a 6 in them. That's not one of our choices. Okay, let's see, are they both divisible by 2, for example? Or we could, rather than do it ourselves, we could just kind of check off this list here. So let's start here with this x minus 3. To get to x minus 3, let's go ahead and GCF it. So each one I can take a 6 out of. We just discussed that. And there's my variables, x squared and x. So that I take out the smaller one, just the x to the first. And when you figure out what's left over, let's see, you just divide away that 6 to the x from the first term. The 6's would cancel. 1 of the x's would cancel. Divide this by 6x. 18 divided by 6 is 3, and the x's just knock each other out. So if I GCF this original problem, I can see the factors are a 6x and an x minus 3. So this one is a factor. And we could also say that like 6 is a factor, x is a factor. And 6 can be broken up. 6 is a 2 times a 3. So 2 can be considered a factor, so that's a factor. X is a factor. We can see him right there. We took him out. He was also a greatest common factor. But 12 doesn't come out of everybody. So, I don't know. Kind of a weird question to me because usually you just want the greatest one. You aren't looking for a list of all the different factors necessarily. Which of the following prime numbers is not a factor of the integer 330? So if you're allowed a calculator, you just quickly go, hey, does 330, is it divisible by 11? Is 330 divisible by 3, by 7, and by 5? If you got to check them by hand, you got to do long division. This goes in there, 330 times? 3 goes into 330 110 times. So yeah, that's a factor. Yes, that's a factor. 5 certainly goes into it because if you end in 0, 5 goes into you. I'm guessing not divisible by 7. If you didn't know for certain, you could do long division. 4 times 28, got to subtract. That's a 5. Bring down your 0. 6 times, 7 times. 49. Yeah, remainder 1. So that guy's not a factor of him. And last couple here, little word problems here. The area of a rectangular shape is given by the product of its width times length. So I would always draw a picture of these things. if the area of the rectangle is, oh man, this has got quite the area. Area is 15x squared minus 35x, and its width is 5x, then find an expression for the garden's length. So essentially, this problem is saying this: area is length times width. Area is 15x squared minus 35x. And that is equal to some L, which we don't know, and W, which they told us is 5x. So it'd be awesome if we knew how to do some division right now. I could divide this by 5x, divide this by 5x, and you kind of can. But he hasn't probably shown you yet how to do that. So what we'll do here is we'll just factor this side. And how will we factor it? We'll factor it by taking specifically out that 5x. So I'm going to, it could be the greatest factor. It may not be. I don't really care. I want to make sure, though, I pull out a 5x, because whatever's left over, by default, must be the length. The area is length times width. The width is 5x. If I take out the 5x, this will be my length. And so I'm going to just take this 15 and divide it by this 5. I'm just factoring that out of there. And that would leave me with a 3. And if I take out, let's get a darker green here, leave me with a 3. And if I take an x out, that'd leave me with a single x. Again, I am just dividing it by 5x here. 15 divided by 5 is 3. X squared over x. One of the x's cancel. And I'm dividing this by 5x, and that leaves me with a 7. 35 divided by 5, and the x's cancel. And so this product is equal to 15x squared minus 35x. And so this must be the length. The length would be equal to 3x minus 7. Number 11, the volume of a particular rectangular box is given by, so V equals 50x minus 2x cubed. So volume is length times width times height. So multiply all these dimensions, and it looks like they've given us the height. They've given us the depth here. I don't know if they're calling that width there, maybe. Find the width. So nope, they're calling this the width. All right. So the volume has to be equal to, this is kind of bad notation here to have those continuous equal signs like I did, equals 2x times some question mark that I don't know times x plus 5. So my task now is to write this green side, so it's got a 2x somewhere and an x plus 5, and then whatever's left over is this side. All right, so let's start factoring it. And I'm just going to take out the GCF. So I look at my numbers here. I got a 50 and I got a 2. I look at the smallest one. 2 is only divisible by 2. That's the biggest thing and the only thing that goes into 2. Thank goodness 50 is also divisible by 2. So we're going to pull a 2 out of both of those. And I'm going to go ahead and start my little division now. So I take a 2 out of the 50. That leaves me with 25. I take a 2 out of 2, and that leaves me with a 1. All right, be a minus sign in front of it. Now let's check our variables here. So I got an x to the first. This got x's in it, but I always take the least number of x's, so it's an x to the first I can pull out. So I'm going to take that x out. That takes the x away from him, so that first term is just 25. I take an x out of him, and I get x squared because it cancels one of these out. All right, so if you remember our steps way back up here at the beginning, we said when you're factoring, start with GCF, then check for a step 2, and one of those steps is count your number of terms. And this one has 1, 2 terms. It's got that minus sign. It's a squared. This is that difference of squares. And again, remember, it's just going to be a squared minus b squared. That's the two things that are squared. Like this right now is a 25 minus an x squared. You see how those don't look like squares? This one does. Actually, I know what a or what b is here. B is an x. But this one doesn't have the squared on it. That's why we square root the 25. And when you square root 25, you get 5. So 5 squared minus x squared. And when you do this, this really helps you see what a is. A is just what they square. They squared a 5 to get 25. So a is the 5. What they square to get x squared, they squared this x. So this thing factors as a 2x, and then the difference of squares. A is 5 minus b, which is x. A is 5 plus b, which is x. And I think we got our problem solved because 2x is 2x, so that factor is this one. X plus 5 is this factor. They've got it written in the other direction, but 5 plus x is equal to x plus 5. So this little factor must be this question mark, 5 minus x, or if you want to put the x first, negative x plus 5. Either one of those would suffice for an answer. And then the last one, projectile. So we're launching something in the air, launch from ground level. So there's the ground. We should put it grassy so it's green. And we launch something from the ground such that its height as a function of t. I'm going to make a little scale here. There's height. This is time. And height as a function of time is given by this equation. Now notice, I want you to be clear here. This is not the projectile flying through the ground. This is our flying through the air. This is the projectile going up and probably coming straight back down. But the reason we get this path, and it looks this way, is because the height is changing as time goes by. So here the height of it, like if I was measuring this against this, what the ball was actually doing, this would be like the ball is at 0 height right here at this time. Then at some time later, it'd be this high, or it'd be right here if it was just going straight up and down. So this is your height, and this is your time, and the height of the ball is going up, getting higher, and then the height of the ball gets lower. The ball went up, then the ball went down. Okay, written in factored form, this equation is equivalent to. So I explained all that, and you don't need it. Sorry, they just want you to factor this thing. So let's check it. We got a 16 and an 80. So the first thing you check is 80 divided by 16. We know 16 is, and 80 is. If you throw 80 into your calculator and divide it by 16, I'm running out of room here, that comes out to a 5. So I've got h of t. I'm going to erase. I don't want to erase my drawing though. So I'm going to do it down here, the black section. So here's my function. It's something you can see. Oops, not in function notation, but it could be. Negative 16t squared plus 80t. I'm going to pull out a 16 because I know 80 is divisible by 16, and 16 is. And for this one, if I look at their answers up here, they pulled out a negative sign. So I'm not just going to take out a 16, I'm going to take out a negative 16. Okay, so now I'm going to divide these by a negative 16, and I put my parenthesis too close because when I check my variables, t squared, t, so they have t's in common, I take the smaller exponent one, so t, leaving me with, so I got to divide this by a t also, so the t's gone down by 1 degree, so it's t to the first. This is going to be a positive now. Negative over negative is positive. 16 over 16 is 1. And this t to the first, I'm not going to show the 1. And then my last one, 80 divided by negative 16. So it comes out to not just 5, but negative 5. And that t is gone because I have divided away the t, if you recall. I had to take that one out as well. All right, so we got it factored. So negative 16t plus 4, negative 16t minus 5. There he is. We found him. Now, real quick, I want to point this out. You guys will be solving these guys next. And so this equation right now in factored form, this problem actually kind of describes this graph a little bit. For example, if t is 5, so after 5 seconds, if I plugged that number in there, 5 minus 5 is 0, the height of the ball, it would be 0 then. This would be like h of 5 is, plug in a 5, and you get 0 out. And so that would tell us like after 5 seconds, its height is 0. That's when it hit the ground. All right. If I plug in a 0 for time, t is 0, I'd get 16 times 0, which is 0 times anything is 0. That would be times 0. The ball's at this height. And somewhere between 0 and 5, it was at its maximum height, way up there. And that'd be right in the middle at 2.5 seconds, right between the 0 seconds and 5. All right, that's it. Hope that helps you.